wonder what happens if vulnerabilities exist in financial applications or HR applications with all that employee data or healthcare with all that medical information. So it goes into the sanitize method, does that regex match, identifies that the URL is not safe. Number one OWASP vulnerability, broken access control. And this includes cross-site request forgery. Cross-site request forgery occurs whenever the application shares session cookies to untrusted sources. All these different ways Angular keeps us safe by using Angular's building blocks and built-in security checks and interpolation and property binding, we have security. So hello everybody, I'm so excited to be here and have a chance to talk to you about safety in Angular, which is perfect because this month, October, is Cybersecurity Awareness Month. So what a way to get started. Make sure that I have focus. All right. So it's also though Halloween, right? So that means that it's time for scary tale. So let me start this talk off with a really frightening tale. Let's say that you're a fan of K-dramas and you work on a K-drama fan site. On this fan site, you can navigate to an individual K-drama to add comments. So one day you do that, since you are the owner of the site, to add comments about your favorite K-drama. And when you're there, you see that there's already awful comments written in your name. And you know you're not the one who would add such awful things about your favorite K-drama, right? Oh no, what do? How do we stop this from happening to other K-drama fans? Well, we need to make sure we add security to our site because web vulnerabilities can cause risk to our assets. And those assets include our application, our data, end users and their data, as well as our reputation, not to mention it affects the bottom line. What this means is that it all adds up to liability. And that's a big, scary word for business decision makers and for financial folks within your company. They don't want liability. So we, as web developers, have a responsibility to make sure we're integrating security best practices into our everyday tasks and making sure we're doing that throughout the process, because this isn't something we can just throw over the fence to the security team at the very end. So who am I to be talking to you about this? I'm Alisa Duncan. I'm a senior developer advocate at Okta, an Angular GDE, core team of Medgy Girls, and you might have guessed that I'm a fan of K-dramas. You can find me on assorted social channels at Alisa Duncan. But I'm also just a regular dev, which means I'm not a security expert. However, through my job, I was afforded the opportunity to dig around in Angular's code base to look at security measures, and I found such great stuff in there that I wanted to share it with you today. You can't talk about web security without talking about the Open Web Application Security Project, or OWASP. This group's sole mission is to make the web a safer place. And it has a lot of different resources, documentation, and content to help us do so. One of the projects of OWASP is the OWASP Top 10. This is a prioritized list of web vulnerabilities, and it is identified by the number of incidences that it comes across of each of these vulnerabilities, as well as the impact of those vulnerabilities. And periodically, this list is updated, the most recently being in 2021. So today, we're going to talk about two of the items on this top 10 list, the number one item, broken access control, and the number three item, injection, starting first with injection, which includes cross-site scripting, the bane of web developers, right? Cross-site scripting occurs when there's not good data and code boundaries and values. And then we take this polluted value and incorporate within our application, which allows attackers an avenue to perform unauthorized actions. So an example of a cross-site scripting attack is that K-drama fan site, where we can navigate an individual K-drama to add those comments. The hope is that comments are written in plain text and are very, very sweet and probably contains a lot of heart emojis. But that's not how it always is, right? There's always some jerk out there. And somebody adds a comment like this, where they're trying to take advantage of a vulnerability within your application. So this comment is added to the K-drama fan site and then saved to the database. Next time an unsuspecting K-drama fan arrives at the site, they see that link for free prizes. And who isn't tempted to click on a link for free prizes? We all love free prizes. So they click on that link and they see this JavaScript alert that says, yikes. Fortunately, a JavaScript alert is startling, but otherwise not dangerous. Nothing really happened. However, the precedent that it sets is incredibly dangerous because once an attacker is able to successfully run their script within your application, they can impersonate you, they can perform unauthorized actions, they can read and capture sensitive data, including your login credentials, and even run malware against your machine. I happen to think that K-drama fan sites are incredibly critical, right? But you may also be thinking about the apps that you work on. So consider what happens if vulnerabilities exist in financial applications or HR applications with all that employee data, or healthcare with all that medical information about people. Furthermore, consider what happens if that attacked user has elevated access within the application. Now they're able to see even more sensitive data or perform even more impactful actions. Oh no. So we need to watch out for cross-site scripting anytime there's poor data hygiene and that pollution of data and code. And anytime we're adding that untrusted data into our application via injection sinks. Fortunately for us, Angular is highly suspicious of the values that we add into the application and treats it all as untrusted and handles the data hygiene for us, which means that without any effort on our part, we have security when we use Angular. And I want to tell you about how that works. Anytime that we incorporate values within Angular using interpolation, Angular automatically escapes it. So we take a look at an example comment and use interpolation to add that to the app. Even if the comment is a purposely broken image that runs an alert upon failure, what we're going to see in the application with this comment added is the text for that comment exactly as is. It's been escaped. And it means that there's nothing for the browser to interpret run here because it's treated as just plain text. And we can verify that by inspecting the element and seeing that paragraph tag with that comment there as plain text. Whenever we incorporate values within Angular applications using property binding, Angular automatically sanitizes it. So if we look at an example, oh, I'm so sorry. So I didn't explain what injection sinks are. So sinks are web API functions that allow us to create dynamic content that we expect today in the web applications that we create and use. And that information includes methods that append to the DOM, such as enter HTML, approaches to load external resources. That's an image's source, anchor tags href, or even a styles URL, and event handlers. So now let's take a look at an example. If we property bind an inner HTML to the comment, and that comment is that purposely broken image, what we're going to see is a broken image. If we inspect that element, though, we see the image element with the source, but no error function. And we'll also see that Angular gives us a warning in the console saying that it has sanitized some HTML and removed some content. So let's take a look under the covers of what Angular does for its sanitization process. After Angular has lists and lists of safe elements and attributes, and after Angular builds out the view that we'll be looking at, the tree for the view, it then traverses through the tree, looks at every element attribute to verify that it is safe for us to see. If we take a look at the code that does this element traversal, we see that there's a lot going on. So we're going to step through this in detail to make sure we truly understand every line of it. Or not. Let me summarize it for you. It's a lot of tedious work that we don't have to do. But I want to draw your attention to these lines of code. This is the list of valid elements, the list of valid attributes, and a list of attributes that explicitly require sanitization. So if we walk through this example with the broken image, what happens is the image tag is first evaluated, and it's identified as a safe void element, and so it is allowed to be continued to be evaluated by the element traversal code. Next, it goes to source. Source is a URL and explicitly requires sanitization. In our case, though, there's really nothing to sanitize. It's safe, right? It's just a value of 1. So it's allowed to be retained, which makes this image element a valid HTML element. And that's why we see that broken image in our application. Next, it moves to the on-error attribute. The on-error attribute is not a safe attribute, and that's why it's removed. If we change our example to another one that we looked at earlier with that free prizes here link, if we view this in the application with property binding, we see that link for free prizes. If we inspect that element though, we see the paragraph tag with the anchor tag with an href of unsafe :JavaScript alert and a warning that Angular has sanitized an unsafe URL. URLs require sanitization, and there is a regex pattern that it follows to ensure that it is safe. So it goes into the sanitize method, does that regex match, identifies that the URL is not safe, which is true, it is indeed unsafe. And that's why we see that console warning appear, as well as where Angular prepends the unsafe : to the URL, which makes it so that the browser is no longer able to interpret and run that link. And when you try clicking on it, nothing happens, which means that we're safe. Angular also allows you to add safe markup. Let's say that you want to allow rich text editors within your application, for example, or you want to allow your K-drama fans to add a comment like this that says it's a wonderful drama, the best in strong font. They're able to do so, and we could see that the output is it's a wonderful drama, the best in strong font, because strong is a valid inline element. Angular also protects us against something called mutation cross-site scripting. And I want to call this out intentionally because cross-site scripting is really sneaky. There's all sorts of different flavors of how attackers can do so. And I feel like mutation crisis scripting is a particularly sneaky one. This is where HTML that was previously inert, that is safe, becomes unsafe through the process of the browser rendering the markup. This might happen because the attacker intentionally puts in a typo, and browsers are really helpful and will autocorrect it for us, but it makes it unsafe. How Angular helps us out is by repeatedly checking each one of those elements and attributes and traversing through that tree during the entire markup rendering process to verify that the final output is safe. How thorough is that? So as you can see, without any effort on our part, when we use Angular constructs of interpolation and property binding, we have safety. And Angular does the hard work of that data hygiene for us, of escaping the sanitizing, so we don't have to. So always use Angular constructs anytime you can, because when you do, you have the most amount of safety. Now, there might be a reason where you want to bypass Angular security mechanisms. I will warn you when you do this, you're entering into some really dangerous territory, though, because you aren't getting yourself the protection mechanism that is afforded to you built in by Angular. But there might be legitimate reasons why you do this, like when you legitimately need video trailers in your K-drama application. So in this case, what we're going to do is we're going to bind a link to an iframe so we have this video player. Now notice that in my example, I'm calling out that it is a trusted video link. You want to do this and make sure that that value you're passing in is trusted, because you're not going to get that built-in sanitization. So you could potentially be opening yourself up to vulnerabilities here. So you want to make sure that you are trusting this link as much as possible by limiting the attack vector. If we take that iframe and put it in a component, what we'll do is inject the DOM sanitizer. The DOM sanitizer has methods to bypass security trust for the type of value that we're trusting, in this case, a resource URL. And we're passing in a safe link. That safe link right now I have hard-coded in the application. So I mean, clearly we wouldn't really need to do this. But imagine that some of that value comes from some external source. What you want to do is limit the attack vector by making sure that you are only allowing the smallest little bit that you need available for input. So we are defining the video hosting site, for example, and forming that URL and only allowing the video ID, for example. But once we have the safe link as possible, we'll pass it into that bypass security trust method for the type of value we're trusting, and it returns a safe type of value that we're trusting. This signifies to Angular to skip sanitization so that we can see the video player. Now, the reason why we have to do this legitimately is because resource URLs have bits of code in them so we can view the videos. So we have to bypass sanitization in order to have this video player. I mentioned the type of value that we're trusting a couple of times, and what that really is are security contexts, of which Angular defines 5. You don't include none, that is. Angular defines HTML, style script URL, and resource URL. And the reason why it does this is because sanitization is contextual, meaning that the way you sanitize for these different elements are different. So we have to be explicit and tell Angular what type of value it is. If we take a look at the implementation for the DOM sanitizer, we see that there's a bypass security trust method for each one of those security contexts, as well as an explicit sanitize method that we can call where we're passing in the security context. Once again, sanitization is contextual, so we have to be explicit. This method, deep down under the covers, will call in Angular's internal sanitization methods as well. You might be wondering, though, as I'm talking about security context and sanitization being contextual, why didn't we define what type of value that we were working with when we were doing the property binding earlier within our HTML? We didn't have to say it was an HTML, for example. That's because Angular tracks which security context to use based off of the attribute you're binding to. So if we take a look within Angular's code, what we see are maps where there's a security context type defined for the type of attribute, in this case in our HTML. So we didn't have to pass anything in. Angular just knows how to sanitize it for us. So just because I talked about bypassing security, I want to call out once again with a great warning that with great power comes great responsibility. Because you can bypass Angular security doesn't mean you should. You shouldn't. You should always use Angular constructs and rely on that built-in security mechanism. If you do have to do this, though, legitimately have to do this, make sure you get a security audit so that you are limiting the attack vectors and trying to keep yourself as secure as possible. Now let's talk about the #1 OWASP vulnerability, broken access control. And this includes cross-site request forgery. Cross-site request forgery occurs whenever the application shares session cookies to untrusted sources. And an example example CSRF attack looks like this. Let's say that you're doing some online banking and your bank uses cookies to manage sessions. Next, you check your email and you got this kind of fishy email and you click the link. Hey, you know what? It happens to the best of us. Those attackers are really, really inventive in the way that they set those malicious emails, right? So you click the link. Unfortunately, though, the sender of this email is an attacker who is targeting your bank because your bank has some dubious security practices. So you clicked on the link and you were sent to a malicious site that made a forum post back to your bank, Yikes Bank, asking for a money transfer. Because you had that active session cookie and the session cookie wasn't guarded, you sent it along to the malicious site that turned around and forwarded it to your bank. Your bank gets this request, sees the active session cookie, and processes the transfer, which means that the attacker is able to walk away with your hard-earned cash. So there are some mitigation strategies that we can employ. One of them might be to not bank at Yikes Bank. But on top of that, we can also protect our cookies by using built-in browser capabilities. And this is something that Yikes Bank should be doing. On top of that, though, like the same type attributes, the same type property on cookies will be really protective here, and that's probably good enough. However, not all browsers support that, so you might need to have extra protection. And that mitigation strategy involves your backend providing you a CSRF token cookie. It's a special cookie that has a value inside. The front end will pass that CSRF token cookie back to the backend whenever it makes a call. Plus, it'll take the value of that cookie and then pass it in a secondary source. The backend then does verification to ensure the authenticity of this request by checking the CSRF token cookie value with that secondary value. This mitigation strategy is called the double submit cookie pattern. How Angular helps us with that double submit cookie pattern is that it has built-in support for it to send that CSRF token value in a API header, and that's what the backend could use for the verification. So if we take a look at the HTTP client XSRF module, what we see is it provides an interceptor, which is the part that takes that cookie value and adds it onto the API headers. And you also have a way when you incorporate this within your application to configure the cookie name and the header name as well if you don't like the defaults. Now, if you are a fan of standalone, you don't want to use modules anymore, you can also use the provide HTTP client method. And this gives you XSR protection just out of the box. It has a double submit cookie pattern built in. You can also pass in a configuration method if you like to override the default values. Lastly, the bulk of the #1 OWASP vulnerability broken access control includes the accidental elevation of privilege. This is where somebody who doesn't have the access levels they should is able to view data that they shouldn't, or is able to perform actions that they shouldn't. Now, in this case, there's active work we need to do as developers to implement these access control checks. This isn't something Angular can provide for free because access control measures are so unique to each software system. However, Angular gives us the building blocks that we need to implement the access controls. And those building blocks include route guards, so you can protect certain routes based off of access control measures. You can also use structural directives, such as the ngIf or control flow, or you can even create your own custom directive if you have highly complex access control checks. And you can also use interceptors, such as adding the authorization header to outgoing calls or anything else that your software system might need. So as you can see, all these different ways Angular keeps us safe by using Angular's building blocks and built-in security checks and interpolation and property binding. We have security. And when we need to add access control measures, Angular gives us the way to do that as well. If you'd like to learn more about this, then you can check out I have a 4-part series about web security, specifically with Angular. It's in that bit.ly link. You can also check out all of the code for this project. I have it on my GitHub. It's got all sorts of information about what we looked at today, examples, as well as it's a really good starting place for creating your own K-drama fan site if you'd like. My slides are available on my site. And if you have a Pluralsight membership, then you can also check out more about this on a Pluralsight course I wrote. Finally, feel free to reach out to me at Alisa Duncan if you have any questions about auth, about security, or if you want to talk about K-dramas, because I love talking about that. Thank you very much.
Thank you, Alisa, for this great presentation. And I have to totally agree with you that even that most of that are not the security expert, we should try our best to make our apps as secure as possible, utilizing everything that our framework provides us with. And
yes.
Yeah, and before we jump directly to the Q&A session from the community, I would like to ask you one more question. Maybe it's not strongly related with your presentation, but might be also very interested for our community. So okay. What is one of the most awaited feature from upcoming Angular 17 version?
Well, I don't know about everybody because there's just so much out there that's so exciting. But for me, I think I'm interested in hearing more about control flow and seeing how that works. It looks like it's really ergonomic and also highly performant. So I'm excited to see usage of that and also how it grows as we utilize it more and want to use it for even access control measures and things like that.
Yeah, that's one of the most exciting for me as well. So I will jump directly to the community questions. We have already the first one.
Okay.
So Domin asks, are there any third-party tools to validate if my website is safe?
Yeah, that's a really great question. And the answer is yes. Thankfully, OWASP does have different projects out there that will do different sort of checks and like penetration testing and things like that. So I would recommend checking out OWASP's documentation and projects. They have not just tooling, but also even a testing guide to walk through as well.
Okay, thank you. There is another question from Sonic Walk. There are too much lists to be memorized. Any tips that we can remember easier?
Too many lists. Okay, well, I think I want to refer back to OWASP again, because if you're going to look at one top 10 list, I actually may not even suggest the OWASP top 10. I might recommend another top 10 list they have, which is called, I think, the OWASP cheat sheet. It is exactly what developers need, written for developers on how to create secure applications. Now, some of the stuff in there is not Angular specific though, right? But those are the things that we should always keep in mind.
Okay, thank you. So if you guys have any additional questions, there is the time to ask. Let us wait maybe a while. Maybe some other question will pop up. Okay, then it seems, Alisa, that will be everything from our community. And
right.
for us, we have one. So
okay,
let me bring it on. Oh, I don't know how to properly spell your name, so I'm really sorry. And the question is there any advantage of using Signet double submit cookie versus the much easier custom request header approach?
I'm trying to understand this question. Are you talking about why? Well, I mean, I wonder if there's something different with the signed double submit cookie. The double submit cookie pattern does pass in the value of the CSRF token in a secondary source, which happens to be a custom header approach. So that's why I'm getting a little maybe confused by this question, but the recommendation is to use the double, there's two different sorts of patterns. The double submit cookie pattern is what we should be using for SPAs. The other one is for more traditional server rendered applications. So I would recommend doing that. That's the one that is recommended by security experts. And anytime we try to roll our own way around security things because for ease of use is when we can get into trouble, right? So I try to follow security best practices from security experts because I'm not one. And so I'd rather make sure that I'm following the recommendations from people who are doing this in the field.
Thank you. There is another question from Sonic Walk. Injection is not the same dependency injection, right?
Yes, that is correct. So in this case, injection is injection-related attacks. So this is where a attacker can submit values to you that contains bits of code, and if you are not properly handling those values properly, you can have problems, which is not the same as dependency injection within Angular. That is a programming pattern.
Okay, we have the additional comment from the Falgun. So I don't know whether it will bring you some context to your answer and whether it will somehow change it for you. But
I'm sorry, I don't know if I can answer this question because I mean it is using a custom request header, so I feel like we're talking about the same thing here.
Okay, so that seems like everything. It's been an absolute pleasure for having you as a speaker today. Your presentation was informative and inspiring. Thank you for sharing your expertise with us. And I hope to see you again in the future meetups and see you soon in Poland because we'll have occasion to see it.
Yes, looking forward to meeting you next week.